So hello, yes, myself and Elaine are joining you this morning then to talk to you about the nitrous oxide project and the work that we've done in Cardiff and Vale. I'm going to start hopefully by playing a video which just gives you a nice overview of the project. So fingers crossed this works.
Nitrous oxide is mostly used by anaesthetists, and we use it when we give a general anaesthetic. We often use it to help put patients to sleep, but we can also use it as a form of pain relief as well. We could show that only about 2.5% of what we bought ever reached a patient. So we identified that about 97% of all the nitrous oxide was being wasted in some way. Working with pharmacy and estates and clinical engineering was really key in solving this kind of problem of where it was all going. So estates did some testing on our nitrous oxide supply systems. We identified two main areas of waste. One was that when our nitrous oxide cylinders are completed, they usually have a bit of nitrous oxide still in them, which gets returned to the OC and is then vented into the atmosphere. And then the second place that it was going was through lots of multiple micro leaks in our pipework systems. When you look at the map of the nitrous oxide pipework and supply, it's massive. So any pipework that's got, multiple connections and miles of pipework, it's inevitable that there's going to be some leakage.
Nitrous oxide originates from a manifold system way deep in the basement of the hospital and goes through loads and loads of pipes and ends up coming out of the wall over here. So the project aims to remove the use of nitrous oxide through the manifold system and instead plumb the nitrous oxide gas into an anaesthetic machine using a much easier, simpler system where the nitrous oxide is bottled into cylinders. There's about 3,000 liters of nitrous oxide in the cylinder. And we use a special regulator that's very clever and indexed, so it's special and safe just for nitrous oxide. It will plumb nitrous oxide correctly at the right pressure with the same piping that we would normally attach to the manifold system to the back of the machine. And then we can deliver the nitrous oxide to the patient.
They have shown that that system is 74% efficient. So actually the amount of wastage, if we use this new system, is much, much less. It also means that rather than having it coming through leaking pipes, we now just have a portable cylinder that can be moved to where it's used. So now the sort of supply of nitrous oxide much more meets the demand, and we don't have an oversupply in a wasteful system anymore. Our next part of the project is to look at Entonox use. We've identified that we buy a lot of Entonox. And again, if we can start to reduce our Entonox consumption, then we will be able to make big savings on our carbon footprint. We're going to use a slightly different approach because we use a lot more Entonox than we did nitrous oxide, and we use it in a different way. So we're going to have to be a bit more creative about how we tackle that problem. But now that we've got that foundation of a good team that's all on board with it, I'm hoping that we'll be able to be successful with that as well.
Okay, thanks everyone. Hopefully you can now see my slides. Let me know if you can't, I'll just carry on otherwise. So yeah, that video was made by Catherine Peel in the Health Board and gives us a really nice overview of what we've been doing with the nitrous oxide project. So I'm just going to go through the goals of the project, some of the QI methodology that we used, what we've achieved, and then what's next for the project. So this really was a partnership project between multiple departments. So key kind of involvement was from pharmacy, clinical engineering, estates, and also clinicians, mainly anaesthetists. And it was initiated by Amarantha Fennell-Wells, who has got a background in dentistry and had a year's fellowship with the Welsh Clinical Leadership Post. And she really kind of helped to build the team and identify the problem with nitrous oxide. We know that nitrous oxide is a greenhouse gas and it's got a global warming potential 300 times greater than that of CO2. In Cardiff and Vale, we were purchasing about 1.18 million litres of this gas each year, and that's equivalent to about 680 tonnes of CO2. And the goal of the project essentially was to reduce emissions from that gas. We're seeing a revolution in healthcare at the moment towards more sustainable practice, and there's wide recognition that healthcare contributes significantly to the total UK's emissions, about 5.6% in total, so we are big contributors. Our government in Wales have recognised this and formally declared a climate emergency and published the decarbonisation plan, which does specifically talk about anaesthetic gas reduction as part of that. Cardiff and Vale made a commitment by joining the Global Green and Healthy Hospitals initiative, and we now have the Greenhouse Wales network, which is there to help facilitate these kinds of projects. So for our project, we built a team made up of clinicians. So Steve Froome, who you also saw in the video there, and myself from Anaesthetics. We had Joe and Ed from clinical engineering, and we've had involvement with estates. So initially Norma Mitchell, then Rob O'Connell, and now we've got Ian Fitzel working on the project with us. And then within pharmacy, we started with Daryl Baker, who chaired the group, and Elaine really has been key in a project management role within this project. As well as the key members of the team, we also had widespread stakeholder engagement from all the other anaesthetists, theatre managers, theatre staff themselves, and also midwifery teams too. So the QI methodology that we used was really key actually in gathering data and being able to demonstrate the problem, and then what we were doing about the problem, whether it was working or not. Nitrous oxide generally is just used by anaesthetists as part of a general anaesthetic. It gives pain relief, but it also helps to sedate patients as well. You can also buy nitrous oxide as Entonox, which is a 50% mixture of nitrous oxide with oxygen, and that's what's used in maternity for gas and air in labour, but also in other areas of the hospital like ED and endoscopy. So the data that we looked at how much we purchased as a health board in terms of nitrous oxide, and we got this from BOC, who is the company we buy it from, and we showed we bought 1.18 million litres each year. We then wanted to work out how much we actually use, so how much ever reaches a patient. And most of our anaesthetic machines actually collect data on the volumes of gas that flow through them. So we conducted like an audit really of our anaesthetic machine data. And from that, we could account for about 27,000 litres of nitrous oxide per year. This isn't perfect data, it was very much QI methodology. Not every single anaesthetic machine recorded its volumes, and we only collected data over a couple of months period and then extrapolated to the year to give an approximate amount. Even if this is quite inaccurate, it does show that only about 2.5% ever reached a patient. So 97% of what we were buying could not be accounted for. It didn't seem to be getting to patients. So where was it all going? As you saw in the video, nitrous oxide is mainly delivered through a piped supply, which originates in a manifold system, which you can see a picture of here. Throughout that supply of the pipework, there's connections, and there's also, more importantly, wall outlets throughout the theatre suite. And there's lots and lots of these, and they can, over time, lead to micro leaks where rubber bungs slightly degrade or connections aren't as good as they used to be. Our estates teams did some leak testing on our manifolds. We have 4 in the health board altogether, 1 for the dental hospital, 1 in St David's Hospital, 1 in Landock, and 1 for the main UHW site. The Landock and the UHW sites are the biggest consumers of nitrous oxide, and when we leak tested those, we did show that there was significant wastage within that system. We then looked at how clinicians were using nitrous oxide, and we did a survey of anaesthetic practice, which showed that actually it was used fairly infrequently. There's a small number of specific situations where anaesthetists use it. For example, a gas induction, so when you put a patient off to sleep by breathing in the gas, and an obstetric general anaesthetic, and for short stimulating procedures. So most of the time, most of our staff were not using nitrous oxide in their daily practice. And I think the low volume of gas that ever reaches the patient really reflects the fact that we don't really use it all that often. And therefore, do we really need a piped supply of this gas if it's causing so much waste? So clinical engineering then came up with a pilot solution to the piped supply, which was this portable E-size cylinder fitted with a regulator, which has a Schrader valve connection so that our anaesthetic machines could plug directly into a small cylinder supply. And this is the supply that you saw in the video. We did a 6-week trial to see how we got on with it from a practical perspective in terms of staff working with it and whether or not it delivered nitrous oxide effectively, but also from an efficiency perspective as well. Was this actually going to be better than the piped supply? We had to buy a regulator and a trolley to do this pilot. They were both quite low cost options, a couple of £100 each maximum. And the pilot supply with the portable cylinder showed a massive improvement in efficiency. So the infographic shows the amount of waste with the two different systems. So the light blue cylinders are what reaches patients, and the dark blue cylinders are the waste in both of those systems. So the manifold pipe supply, you can see, produces way more waste than the portable supply. So this was really encouraging and showed us that we could actually make massive savings if we introduced the cylinder supply. So the next step of the project then was to scale this up basically and spread it. So we have at this stage now fully implemented a portable cylinder system in Landock Hospital. What that means is we don't now need a piped supply there at all. And so that manifold has now been fully decommissioned, which is saving us about 300,000 litres of nitrous oxide each year. And work is underway currently to do a similar thing in UHW, with the goal being that our manifold in UHW is going to be decommissioned by the end of the summer. And we really do have an all Wales vision with this project. Other health boards have already started work on this, and we have been working closely in other areas. And I think there's plans to decommission manifolds all across Wales. And I think virtually all manifolds supplying nitrous oxide should be decommissioned. So what can we achieve? In Cardiff and Vale, we project savings once we've completed the decommission in UHW, projected savings of 1.1 million litres of nitrous oxide or 680 tonnes of CO2. It also promotes a culture shift away from nitrous oxide use. There are financial savings associated with this in that we're not purchasing gas that we're wasting, although it is a very cheap gas to purchase, so these are quite modest savings, but also indirect cost savings in terms of reduction in estates workload for manifold maintenance. And an added benefit really that bringing in a portable supply helps kind of align with the work that we're doing and pharmacy are doing to introduce a tracking system for portable cylinders. What's next? So we mentioned Entonox, which also contains nitrous oxide, mostly used in maternity, but also the emergency department and endoscopy. Looking at what we've started to look at this, and we have found that we buy an awful lot of Entonox. So Cardiff and Vale buys about 8 million litres each year, same as 4,500 tonnes of CO2, which equates to about 930 trips around the planet in a normal petrol car each year. That's just our one hospital. And we're going to hopefully be working to save on our Entonox emissions as well. So in summary, moving from a piped supply to a portable cylinder system will cut waste in nitrous oxide, and you can see efficiency improvements from about 2.5% to 74%. The next steps with this project is to start tackling our Entonox emissions, and then also to work alongside other health boards to share our experience and learning to help other health boards across Wales make similar improvements. Thank you very much.